Next 2 days, we are going to be talking about section 10.2, which is on multiplying polynomials. Now remember, we just got done talking about adding and subtracting polynomials and putting our like terms together. So we're going to continue on with this now, only we're going to be talking now about multiplying polynomials. And if we remember back to probably a couple of months ago, we talked about something called the distributive property. And we're going to start out with a couple of examples here on the board that we're going to use the distributive property. And remember, when we use the distributive property, we're going to take the number that's multiplied by a parenthesis to everything inside that parenthesis. So in example A, using the distributive property, I'm going to take the 3 times the x and the 3 times the 4. So 3 times x is 3x, 3 times 4 is 12, and so our answer is 3x plus 12. The same thing is true when we do this with a negative number. We have to take the negative 2 times the x, and that's negative 2x. And then we're also going to take the negative 2 times the negative 7, and that is going to be plus 14. Okay, so we did a lot of problems on the distributive property a while ago. But again, we're bringing that back because that's what we're going to use. So we're going to do the same thing now. And if we remember the terms that we talked about, the distributive property, what we just did, we multiplied a monomial, 1 term, by a binomial, 2 terms. So now if we look at example 1, we see that we have 2 expressions that both have 2 terms. We have 2 binomials. So when we multiply these 2 binomials, we're going to start by using the distributive property. Again, we're going to do the distributive property just like we did in the review example. I'm going to take the x times the x and the x times the 7. So if we do that, we're going to get x squared and then negative 7x. Next, we're going to take the second term, the 8, and we're going to distribute it. So we're going to go 8 times x and then 8 times negative 7. So that's going to be 8x minus 56. So after we do the distributive property twice, we're going to go back and look, is there anything else we can do? Well, we have an x squared, a negative 7x, an 8x, and a negative 56. So if we look at these 2 terms are the same. They both have the same variable part, they're x's, so we can put those together using the addition and subtraction stuff that we did before. So we're going to go x squared, negative 7x plus 8x is 1x. And then our minus 56, and here's your answer. All right, so when we look at the distributive property as a recap, we're going to take the first term, the first binomial, and we're going to take the x times both the things in the second one, both the terms in the second one, and then we're going to take the 8 times both the terms in the second one, and then when we're done, we're going to add our like terms together. So what I would like you to do right now is go ahead and pause the video. We're going to do these 3 problems, and then you can hit play to check the answers. And here are the answers for the guided practice questions 1, 2, and 3. Now notice the first one, I took the x, and then the blue I got x squared plus 2x. And I did that the same way through all of these. So the first term I took x was in the blue, x in the blue, 2x in the blue, all the way through to the other 2. And then I took the second number through to all of those as well. So if we continue on here, you'll see, if using the distributive property, you'll see something called the FOIL pattern. Okay. In using the distributive property for multiplying 2 binomials, you might have noticed that. So what we did is we multiplied the first term. Okay, so if we look at here, let's take the x plus 1 times the x plus 2. So we said that we took this one times this one by doing this. That's the first term. That's f. When we talk about the FOIL pattern, that's f, the first term in each one. The second thing we did was those two. Okay, we went this way. Well, that's 2 times x. And those are the two that are on the outside of each one. Okay, so that's O is the outside. Then we multiplied these two. They were the inside. That's the I, the inside two terms. And then we multiplied these two. And that's the last one in each term. So that's how we get the FOIL pattern. So when we look at this, if we write our FOIL up there on the sheet or on your paper, wherever you're working, then you can just put those together. First, that's going to give us 10x squared. Outsides, multiply those two. Those are the outside two. That's going to be 2x. Insides, that's going to be 15x. And the last two, that's going to be 3. So now again, notice the O and the I are like terms, so we can put those together. So you're going to end up with 10x squared plus 17x plus 3. Which is essentially the same thing as the distributive property, but the FOIL method gives us an easy way to remember that. You'll hear your math teachers talk about foiling for the rest of your life. So FOIL, first, F stands for first, O stands for outside, I stands for inside, and L stands for last. So the foiling is the first, the outside, the inside, and the last. So let's do number 4 together, and then we'll have you take a chance at the other one. So let's go FOIL. So the first terms. What are the first terms? Okay, it's going to be x squared. Outsides. Where are the two outside terms? Right there. So that's going to be negative 4x. The inside terms. Right there. 1x. And the two last terms. Oops. The two last terms. Negative 4. So then we put our like terms together. We get x squared minus 3x minus 4. All right, so go ahead and you can pause the video and do questions 5 and 6. Make sure to use the FOIL pattern as you go through these problems. So go ahead and pause it, and then you can hit play when you are ready to continue. And here are the answers to the guided practice questions, or the checkpoint questions 5 and 6. Again, notice we used the FOIL method on each one of these. To get our answer. Again, F stands for first, the first term in each binomial. O stands for outside, the outside or the outermost term in each polynomial. The I stands for the inside. It's the insidemost term in each polynomial. And then L, it stands for last. That's the last one in each binomial. So again, FOIL method is something that's very, very important. You'll use it a lot. If you don't think you'll remember it, write FOIL right on your note card. So go ahead and write that on your note card. And that's where we're going to stop today. But what I would like you to do is if you go to the bottom of your notes, it'll have the day 1 assignment, and it's on page 578. What I would like you to do right now is do this first part of it. I want you to do 1 and 2, 11, 14, 17, and 20. So do those 6 problems, and then we'll go over them in class. So you'll be able to pause the video, go over them, or you'll be able to go over them, and whenever you're done with those, then you can go on and do the assignment, which will be 21 through 47 odds. So that'll be for the first day. All right, so we can go ahead and stop the video for today. Tomorrow, just resume it at this place. All right, so yesterday we talked about multiplying 2 polynomials that were both binomials. Okay, we used the FOIL method, we used the distributive property. Today we're going to look at what happens if those 2 binomials, or those 2 terms that or numbers we're multiplying are not both binomials. What if one's a trinomial, like in example 3? Well, you can only use foiling if we have 2 binomials. If they're not both binomials, you cannot use FOIL method. You'll have to use the distributive property. So what we're going to do is we're going to look at 2 different ways to multiply these. We're going to do it vertically, and we're going to do it horizontally. And again, just like you did the addition and subtractions, you can do whichever method it is that you like better. Now, today on the assignment, I want you to do some vertically and I want you to do some horizontally so you can see what the difference is between them. But when we get to quizzes and tests, I won't ask you to do this vertically or do this horizontally. You'll be able to decide whichever method you like best. All right, so let's look at example 3. It says multiply polynomials vertically. We always want to pick to take our terms and write them in standard form. And if we're going to do this one vertically, okay, so I'm going to put them on top of each other. I'm going to take that first term and I'm going to write it in standard form. So it's going to be negative 2x squared plus 5x plus 9, or rather the second term. I'm going to take my biggest one, my trinomial, and I'm going to always have that on top. And then I'm going to take my x minus 4 and line them up according to terms again. Notice the 9 and the 4, they're both constants. They go in one column. The 5x and the x, they're both constants. They're going to be there as well. So now what we're going to do is multiply. And I'm going to take this negative 4. I'm going to multiply it by everything above it. Just like we always write out our multiplication, we're going to do the same thing. So 9 times negative 4 is negative 36. Negative 4 times 5x is negative 20x. Negative 4 times negative 2x squared is 8x squared. So now we're going to take the x. Let's use a different color there. We're going to take the x and we're going to multiply everything in that top row by it. So x times 9 is 9x, and again that has to go with my x in my x column because I'm going to just add these up here in a bit. X times 5x is 5x squared. So it's going to be a plus. And then x times negative 2x squared is negative 2x cubed. So now if we look here, the negative 36 is the only thing I have in that column. Well, that means I'm really adding it to 0 because we're adding these. So it's negative 36. We have the negative 20x plus 9x. That's negative 11x. We have 8x squared plus 5x squared, which is positive 13x squared. And then we have the negative 2x cubed left. So when we add those up, add our like terms up after doing the multiplication, that is the answer that we should get for example 3. So again, that was the vertical format because we took the first one, we put it in standard form and wrote it on top. Then we took the second one, the second binomial in this case, and wrote it underneath, and we multiplied those two polynomials. Okay, so that is using the vertical format. And again, a lot of people like this because you write them up there, then you do your multiplication exactly like you have done in the past. Right? So that's the vertical format. Second, we're going to talk about the horizontal format. All right, and so this is the one that I use more often. And I'm just going to start by writing this down, and I'm going to write my binomial first. And essentially what we're going to do is we're going to use the distributive property. So I'm going to take this 6x, and I'm going to distribute it to all three terms. So 6x times 5x is 30x squared, 30x cubed. So it's 6x times 5x squared. And then 6x times negative 6x is negative 6x squared. And then 6x times negative 3 is negative 18x. Now we're going to do the same thing with the negative 5. So we're back to this distributive property. So negative 5 times 5x is negative 25x squared. And then we're going to have negative 5 times negative x, which is 5x. And then negative 5 times negative 3, which is plus 15. And the only thing left to do for us now is to put our like terms together. Well, this is the only x cubed. So we use that one. Then we have 2x squared terms here and here. So we have negative 6 and a negative 25. That's going to be negative 31x squared. And then we have 2x terms, a negative 18x, and a 5x. That's negative 13x. And then we have the plus 15 left. So there is our answer. 30x cubed minus 31x squared minus 13x plus 15. And that's the answer that we get using the horizontal format. And when we do the horizontal format, it's essentially just a distributive property. Okay. Now, you wouldn't have had to rewrite this polynomial as the binomial first. You could have used the distributive property in the original problem by doing this. You could have taken the 5x squared times both of those, then the negative x times both of those, and then the negative 3 times both of those. You would have gotten the same answer. But this way, I only have to distribute 2 of them instead of 3, so I usually like writing the one with the least number of terms first. All right, we're going to skip example 5 for right now, and we're going to jump down to the checkpoint questions. We'll do number 1 together, and then we'll have you do numbers 2 and 3 on your own. So again, I'm going to start by taking my x minus 4. And I'm going to take the x, and I'm going to do the distributive property. So x times x squared is x cubed. X times x is x squared. X times 1 is 1x. Now I'm going to take the negative 4 and distribute that. So that's negative 4x squared. Negative 4 times x is negative 4x. and negative 4 times 1 is negative 4. And now we add our like terms together, where it's going to be x cubed on negative 3x squared minus 3x minus 4. So that is how we got that answer. We distributed the x, we distributed the negative 4, we added our like terms together, and there is our simplified expression when we multiply those two polynomials. So what I would like you to do right now is go ahead and pause the video so that you can do questions 2 and 3. And there are the answers for questions 2 and question 3. Notice again in the red, a number 2, I took the x through to all 3 of them. And then in the green, I took the 5 through to all 3 of them. And then I added my like terms. Number 3, we took the 2x in black, distributed it to the trinomial at the back. And in the blue, we took the 1 and distributed it through. And then we added our like terms. So again, if we're multiplying a binomial by a trinomial or anything other than two binomials, you must use the distributive property. The only time you can use foiling is if you have two binomials that you're multiplying together. All right, so let's go back to example 5, and it says multiply binomials to find an area. Now, if we remember, the area of a rectangle is length times width, or base times height, either way you want to look at it. And here it says a glass portion of a sliding door has a height to width ratio of 2 to 1. The frame adds 10 inches to the width and 12 inches to the height. Write a polynomial expression that represents the total area of the window, including the frame. So the first thing we're going to do is draw a picture. So we have a sliding door. It says this is 2x, this is 1. However, we're going to put a frame around it. And so we know it says that 1x says the frame adds 10 inches to the width. So that means from here to here is going to be 5. And from here to here it's going to be 5. And so that's going to be 1x. And then it adds 12 inches to the height. So this is from here to here. It's going to be 6 inches. And from here to here is also going to be 6 inches. So what we're looking at is this. I want to know what is this segment. Well, it's 2x, and it's 6 and 6, so it's 2x plus 12. And this segment is 1x plus 10. So they're saying write a polynomial expression that represents the total area. So remember, area is base times height or length times width. So we're going to multiply these two. So we're going to take our 2x plus 12 times our 1x plus 10, and we're going to multiply these. So again, they're both binomials. What are you going to do? We're going to use the FOIL method. So let's write that. So we're going to talk about the FOIL method. We're going to write it over here, and we're going to multiply them. First, 2x squared. Outsides, 20x. Insides, 12x. And the lasts, 120. So now we'll see those middle two terms, the outside and the inside terms, are like terms. So we're going to put those together. And so there is our polynomial expression that represents the area of the window and the frame. So today on your assignment, we're going to be working mostly on multiplying two expressions that are not both binomials. So if you look at the day 2 assignment on page 579, we're going to be talking about a couple of word problems, and then we're going to also be multiplying binomials times trinomials. So on page 579, your assignment is numbers 48 through 58, and then 62 through 64.